the presenters today. I'll walk you through the history and origins of the parabola as a conic section, as well as the definition of parabola terminologies. Before I go any further, allow me to briefly discuss our main topic. Parabola is one of the conic sections that we shall explore today. We've seen parabolas that open upwards or downwards as graphs of quadratic functions before. Here we see parabolas opening to the left or right, and last look at how parabolas may be utilized and applied in real life. But before that, let's see what major points you will be learning today. We have a list of learning outcomes of the lesson. At the end of the lesson, the learners are able to define a parabola, determine the standard form of equation of parabola, graph a parabola, and solve situational problems involving conic section parabola, and transform a parabola equation to either general or standard form. Proofs in mathematics such as the parabola were not invented, rather they've been discovered, studied, and put to good use. Parabola has a wide range of mathematical description, long and fascinating history in mathematics and physics, and is still employed in a wide range of practical applications today. Hence, to adequately clarify who developed and examined such concepts that form the parabola as it is now, I'll show you an illustration of a narrative. The discovery of the parabola as a conic section is accredited to the Greek mathematician Conic, who lived in the 4th century BC. He is also acknowledged for the solving of the difficulty of establishing a geometrical construction for the cube root of 2 by employing parabolas. Although Conic was unable to solve the issue using a construction, he did demonstrate that the answer may be found by intersecting two parabolic curves. The area contained by a parabola and a line segment known as parabola segment was calculated by Archimedes using the exhaustion approach in his The Quadrature of the Parabola in the 3rd century BC. Apollonius, who discovered numerous features of conic section, is credited with the word parabola. It refers to the application of Arius' motion, which has a link to this curve, as Apollonius demonstrated. Laplace is responsible for the focus directrix feature of the parabola and other conic sections. Galileo demonstrated that the projectile path follows a parabola as a result of homogeneous gravitational acceleration. To outline the origins and history of the conic section parabola, the concept of a parabolic reflector creating an image existed long before the advent of the reflecting telescope. In the early mid-17th century, many mathematicians submitted designs including René Descartes, Mariano Sena, and James Gregory. Due to difficulties of fabricating a parabolic mirror, Isaac Newton used a spherical mirror instead when he created the first reflecting telescope in 1668. Parabolic mirrors are used in the most modern reflecting telescope, as well as satellite dishes and radar sensors. With that being stated, let us move on to the definition of terminology associated with parabolas. The parabola has the characteristic shape shown above. A parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point in the plane. In fact, para means for and bola means throwing, just like the shape exhibited when you throw the ball in the air. Fixed line is called the directrix of the parabola. The fixed point is called the focus. The line perpendicular to the directrix passing through the focus is the axis of symmetry. The vertex is the point of intersection of the axis of symmetry with the parabola. Latus rectum is the segment having an endpoint that passes through the focus and the parallel to the directrix. Thus, in a parabola, the directrix, focus, vertex, rectum, axis of symmetry may be located and determined. Rhea May will continue by telling you how to find and locate the following elements using a table of guidelines. Hello everyone, my name is May, and presently I'll demonstrate how to solve and identify the following elements you previously discussed, as well as plot them in a graph. We put up a quick reference guide to assist you, which will also make it easier to solve for the elements. The parabolas we considered so far are vertical and have their vertices at the origin. Some parabolas open instead horizontally, to the left or right, and some have vertices not at the origin. Their standard equations and properties are given in the table. As a reminder, we must keep in mind that if the x part is squared, the parabola is vertical. If the y part is squared, the parabola is horizontal. In a horizontal parabola, the focus is on the left or right of the vertex, and the directrix is vertical. For additional information as well, first, vertex at the origin, 0 and 0. If the parabola opens upward, the vertex is at the lowest point. If the parabola opens downward, the vertex is at the highest point. Second, directrix. The line y equals negative c or y equals positive c. The directrix is c units below or above the vertex. Third, focus. F equals 0c or f equals 0 and negative c. The focus is c units above or below the vertex. Any point of the parabola has the same distance from the focus as it has from the directrix. Fourth, axis of symmetry. X equals 0, the y-axis. This line divides the parabola into two parts which are mirror images of each other. To proceed, I believe we have now figured out how to solve an equation. Let's start by attempting to solve a problem and then applying the brief guideline I provided previously. Example number 1. X squared equals 16y. Let us try to instance the equation x squared equals 16y. Since we already know that the vertex is at the origin, thus we obtain vertex at points 0 and 0. As you can see in the table of guidelines I showed previously, as the value of c is 0, the parabola widens upward. In this situation, because we have the value of c as 16 and it is greater than 0, we can plot the opening rising upward. Next, locate the focus. To find the focus, let us find the value of c. To find the value of c using the table of guide, we have here x squared equals 4cy. In this case, we have 4c as 16, so focus in 4c equals 16. To get c, we have to divide both sides by 4 and then cancel. Now, we have c equals 4 as the remaining value. So c equals 4, meaning from our vertex, the focus is 4 units up. Given the technique, we can say that our focus is 0 and 4. Let us now find the directrix. Since the directrix is perpendicular to the axis of symmetry, so that is 4 units below. Hence, our directrix is 0 and negative 4. We have already discussed the directrix is a line, so we don't have to plot the point 0 and negative 4. Rather, we have to find the equation. Now, we have negative 4 as the value of the directrix. Lastly, we have to solve for the axis of symmetry. Since we already know that the axis of symmetry is perpendicular to the directrix, thus we have the value of x as 0 since our vertex is already the origin along the x-axis. Now, if your teacher asks you what is the length of the latus rectum, it is simply 4c. Since we already have the value of 4c as 16, 16 is therefore the length of the latus rectum. Considering all of the value, we now have the graph of the parabola. Squared equals 16y. Our vertex is 0 and 0. Opening upward. Focus 0 and 4. Directrix y equals negative 4. Axis of symmetry x equals 0. Length of the latus rectum 16. Let's have another example regarding this section. Determine the focus and directrix of the parabola with the given equation and
indicate the focus, directrix, vertex, and axis of symmetry. Example number 2. X squared equals negative 6y. This example doesn't further need an explanation because it is still somewhat the same as what we had earlier. Again, the vertex is understood to be at the origin. So the vertex is at points 0 and 0. And the parabola opens downward because the value of 4c is less than 0. X squared equals negative 6y. Our vertex is 0 and 0. Our opening is downward. Focus F equals 0 and negative 3 over 2. Directrix Y equals 3 over 2. Axis of symmetry X equals 0. Length of the latus rectum 6. Now, what if we have an explanation with the vertex not in the origin or it is in the form h and k? Example number 3. X plus 1 squared equals 16 times y minus 3. As you may have observed, the value of c is greater than 0, so we have now identified that the opening of the parabola is upward. Now, for the vertex, we have it in the form of hk. So we just have to equate 0 from the given. Thus, x plus 1 equals 0, y minus 3 equals 0, x equals negative 1, y equals 3. Therefore, vertex is negative 1 and 3. Let us now find the focus. To locate the focus, we must first again identify the value of c. In this case, the value of c is 16. Therefore, 4c equals 16. 4c over 4 equals 16 over 4. Divide both sides by 4 to get the value of c. So now, c equals 4. Now that we have identified the value of c, let us proceed locating the focus. Given that c equals 4, we must plot that from our vertex we're going to locate 4 units up since our opening is upward. So our focus is negative 1 and 7. Next is the directrix. Since we have the value of c as 4, we're going to locate 4 units down. The directrix would be then negative 1, so y equals negative 1 is our directrix. Now that we've determined the value of the directrix, it would be easier for us to locate the axis of symmetry since it is perpendicular to the directrix and passes through the focus. Therefore, our axis of symmetry is x equals negative 1. Lastly, the length of the latus rectum, which is understood to be 16, seems 4 times the value of c, which is 4 is 16. To sum up our examples in this section of the standard equation of parabola, let us now try an example with only its focus and vertex indicated. Example number 4. Find its standard equation. What is its directrix and axis of symmetry? Given vertex 3 and negative 1, focus 7 and negative 1. The vertex is 3 and negative 1, and the focus is 7 and negative 1. Please, we deduce the following: h equals 3, k equals negative 1, c equals 3. The distance of the focus from the vertex. Since we have 3 as the value of c and it is greater than 0, the parabola opens to the right. Thus, we will use to template y minus k squared equals 4c times x minus h. Finally, our equation is y plus 1 squared equals 16 times x minus 3. Its directrix is c equals 3, units to the left of vertex, which is x equals negative 1. Its axis is the horizontal line through vertex, which is y equals negative 1. All the given value, the result of the graph is. This approach may be used to solve a variety of problems involving calculating the standard equation of a parabola given the vertex, focus, and a number of other factors. Let us now try to analyze and solve an example of a situational problem involving parabolas. Example number 5. A parabolic arc is followed by an item thrown from a height of 2 meters above the ground until it reaches the ground. The determine the horizontal distance between the items' beginning and final position if the object achieves a maximum height of 7 meters measured from the ground after traveling a horizontal distance of 4 meters. Let's vertex 0 and 7 be the vertex of the parabola, which responds to the object's highest point. The equation of the parabola is thus x squared equals negative 4c times y minus 2, and the object's starting point is negative 4 and 2. Then negative 4 squared equals negative 4c times 2 minus 7, c equals 16 over 20, simplify equals 4 over 5. Hence, the equation of the parabola is x squared equals negative 16 over 5 times y minus 7. When the objects hit the ground, the y coordinate is then equals to 0, and x squared equals negative 16 over 5 times 0 and negative 7. X equals 112 over 5. X equals positive negative 4 square root of 7 over 5. Since this point is to the right of the vertex, we choose x equals 4 square root of 7 over 5. Therefore, the total distance traveled is 4 square root of 7 over 5 minus negative 4, or 8.753 meters. That concludes the properties and formulas in the conic section parabola. Simply follow the instructions we've provided, and I'm confident you'll be able to solve any problem. Let us now go on to the next topic in parabola. It will be discussed by Shaina, which is the transformation of equations.
Hi everyone, I am Shaina and I will be the one to guide you in transforming such equations from either standard form to general form or general to standard form. We have also included a table of guidelines to assist you in transforming an equation. So here's our table of guidelines. We have general and standard form. So the formula of general form, we have y is equals to ax squared plus bx plus c. And for the standard, we have quantity x negative h squared is equals to 4b quantity y negative k. If the equation is given in the general form, ax squared plus cx plus dy plus e is equals to 0, a and c are non-zero, or by squared plus cx plus dy plus e is equals to 0, b and c are non-zero. We can determine the standard form by completing the square in both variables. Now let's have a, b, and c as our problem in transforming general to standard form. For letter a, we have x squared negative 6x negative 2y plus 9 is equals to 0. 6 squared negative 6x, move the other expression or other terms on the right side, it will become 2y negative 9. Negative 2y will become positive, and positive 9 will become negative 9. Now we have the square of binomial. That means we need to make our left side a perfect square trinomial. The square of binomial, so our answer will be quantity x negative 3 squared is equals to 2. For letter b, we have y squared negative 5x plus 12y is equals to negative 16. Put the other expression or other terms on the right side. It will become positive 5x negative 16. Now we have a square of binomial. That means we need to make our left side a perfect square trinomial. So y squared plus 12y plus blank is equals to 5x negative 16 plus blank. We need to add blank on the right side to make our equation balance. Now what will be the value of that blank in completing the square? In the middle term, we have 12. Now divided by 2, which is 6. 6 squared is equals to 36. We'll take 36 on the right blank as well to make our equation this will become 3 quantity y squared plus 8y is equals to negative 8x, negative 40. Add the negative 8 and negative 40, that is 48. Also add 48 on the right side term. Now let's complete the equation by adding a blank. What will be the value of that blank? So 8 divided by 2, that is 4. 4 squared is equals to 16. Negative 8x, simplify the expression. Quantity negative 40 plus 48, that is 8. Factor out the negative 8 from the expression. That will become negative 8 quantity x, negative 1. For the square of binomial, multiply both sides of the equation by 1 over 3. That will become quantity y plus 4 squared is equals to negative 8 over 3 quantity x, negative 1. This is now our standard form. So after discussing general form to standard, now let's transform standard to general form of the parabola. We have d and e as our problem. So letter d, quantity y negative 4 raised to 2 is equal to negative 6 quantity x plus 1. For the square root of binomial, we need to expand. So square the first term, that will be y squared. We'll just have to multiply the first term and second term times 2. Negative 4y times 2, that is negative 8y. Then square the second term, that is positive 16 is equals to distribute the negative 6 times x, that is negative 6x. Negative 6 times 1, that is negative 6. Now equate to 0. So we have y squared, negative 8y plus 16 plus 6x plus 6 is equals to 0. Then rearrange and combine like terms. So we have y squared plus 6x, negative 8y. 16 plus 6, that is positive 22 is equals to 0. Now that would be our general form. And for our last example, letter E, we have y squared is equals to 3 quantity 1, negative 1. Just copy y squared, then distribute is equals to 3 times x, that is 3x. 3 times negative 1, that is negative 3. Equate to 0. We have y squared, negative 3x plus 3 is equals to 0. This will be our general form. And now we have addressed all the major aspects of the parabola. Let's put your knowledge and comprehension test. Here is a compilation of the questions and problems that we have prepared. Don't worry, these are only basic and easy. Simply follow the guidelines in the tables we have there. It's your turn. When I flash the questions, just pause the video